Hello everyone, welcome to another video of mine, and in this video I will be solving question number 6 of May June 2013, and the paper code is 32. So this question is related to the topic of differentiation and integration, and we will be using integration by substitution over here as well. So question number 6, I by differentiating 1 over cos x show that the derivative of sec x is sec x 10x. Hence show that if y is equal to ln sec x plus 10x, then dy over dx is equal to sec x. So what we're going to do in the beginning, we have to derivate 1 over cos x and show that it is equal to sec x over 10x. So d over dx. So as you can see over here, what rule is going to be used over here? Quotient rule is going to be used over here. So let me write quotient rule over here as well for you people. So d over dx, it's u over v, which is equal to v as it is, first derivative of u minus u as it is, first derivative of v over v square. So pause the video and try to do this on your own and get sec x over 10x, and then if you can't do it, so resume the video as well. So cos x as it is, and you know that the first derivative of a constant is 0, minus 1 as it is, even if you don't write that, no problem. And the first derivative of cos x is minus sin x. This you are going to need to remember, over cos square x, cos x whole square. And we know that this is going to get cancelled and is going to give us 0 and minus 1, and into minus sin x is positive sin x. And in the denominator, what do we have? We have cos x square. Now I know that I can split this into cos x, and cos x is equal to sin x cos x into 1 over cos x. Now we know that sin x over 10x, this one over here, what is this equal to? This is equal to 10x. And what is 1 over cos x is equal to? It's equal to sec x. This whole, I mean, not only this whole is equal to 10x, and this is equal to sec x. So what do we get? We get, now I'm going to write it as it is written above, sec x 10x. No, it doesn't matter whether you write 10 before or sec before, but if you write it like this, it's much better, I suppose. So, and then we have y is equal to ln sec x plus 10x, and we have to show that it is equal to sec x. So dx ln sec x plus 10x, and what do we have? And this is supposed to be equal to sec x, the first derivative of it. So we know when we have ln d over dx over ln x, so the first derivative of it is that we write it like this, 1 over x, like whatever is written next to ln, we are going to write it like 1 over x. For example, if this was ln 1 over x, so it's ln x. For example, if it was ln x plus 2, so what would have it been? The first derivative of it would have been 1 over x plus 2, right? So now what we're going to do is, like here it is ln x 1 over x, then first we're going to write it as 1 over x, and then we are going to find the first derivative of whatever is written next to ln x. So what is the first derivative of x? It is 1. Over here also, what is the first derivative of x plus 2? It is 1. So this is how we do when we have ln, like this is how we found the derivative of ln. Let me remove this so we can have abundant space over here. So yes, sorry for that, I need to find shortcuts. So uh, now how we're going to do that is equal to, let me write it over here, is equal to 1 over ln, whatever is written next to it, we're going to write it in the denominator, sec x plus 10x multiply by. Now in the first part we have find out the derivative of sec x. And what is the derivative of sec x? It's even given in the question. It is sec x 10x. So I don't even need to do that. So it's simply going to be sec x 10x plus. And what is the derivative of 10x? We already know this. We're going to have to memorize it as well. And I've also shown it in my one of my videos, proved it that it is equal to sec square x plus sec square x. So now, as you can see in the numerator, what is becoming common? It's sec x. So simply take that common, is equal to sec x, and we're going to be left with 10x plus sec x. We have taken sec x common, and in the denominator we have sec x plus 10x. Do you see that this and this is going to get cancelled, and what we are going to left with? Sec x. And we have shown it, we have proved it, and that was what was given in the question, and we have done it, and we are done with the I part. To the second part, where it is this: using the substitution, x is equal to under root 3 tan theta, find the exact value of this, expressing your answer as a single logarithm. Single logarithm means that in our answer there shouldn't be any other logarithm. If it is ln x, so it should be ln x, it shouldn't be ln x minus ln y. And you, I hope so you get the concept of that. So now we have to use substitution over here. Use the substitution, x is equal to under root 3 tan theta. So for at first step, what I'm going to do is I'm going to take the derivative of this respect to theta, because I want to get rid of this dx. So I want to get rid of this dx. In the question they have already told us how to get rid of the x which is given, and then we have to change these limits, because these limits are for x, they are not for theta. So we need them in terms of theta for theta. So that is the reason why we are going to replace these limits as well, and we are going to replace these limits with the help of this substitution, because we already know x. So here it is, dx over d theta is equal to under root 3 as it is, and we know that the first derivative of tan theta is sec square theta. So yes, so now we have dx is equal to under root 3 sec square theta d theta, and now we have to change these limits. So when we know that when x is equal to 1, when x is equal to 1, 1 is equal to under root 3 tan theta, and this is going to become tan theta is equal to 1 over under root 3, and what do we get? Tan inverse theta is equal to tan inverse 1 over under root 3. So when you're going to do this, you're going to get pi by 6. Same for when x is equal to 3, you're going to do same this, just in the denominator. What we're going to get? We're going to get 3 is equal to tan inverse 3 over under root 3, and what you're going to get? You're going to get pi by 3. So you got the limits, you got dx in terms of d theta, and you know that x is equal to under root 3 tan theta, so you can simply substitute all of these in the equation. So the lower limit is pi by 6, we get this as pi by 3, 1 over, remember that this is all over this, 3 plus under root 3 tan theta square multiply by it is under root 3 sec square theta d theta. What we see over here is that this square and this under root 3 are going to get cancelled. So what we're going to get? We're going to get I'm so sorry. I know that the work is very untidy. I'm gonna try to improve it in my next videos, but this is not an excuse for mediocrity. So I hope so that I'm able to improve myself. So 1 over 3, this under root 3, and this is going to get cancelled. So what we're going to be left with, we are going to be left with 3 tan square theta, right? 3 tan square theta multiply by under root 3 sec square theta d theta, right? So what we can see over here is that 3 is common, so we can take 3 common over here. So let me just copy this. I'm able to do that. No, I'm not able to do that. So what do we have? We have is equal to pi by 6 over pi by 3, and then we have 1, and in the denominator we have 3, 1 plus tan square theta multiply by under root 3 sec square theta d theta. So we know that 1 plus tan square theta is sec square theta. So 1 over 3 sec square theta multiply by under root 3 sec square theta d theta. So now what we're gonna do is equal to pi by 6 over pi by 3 1 over, this is going to become under root 3. The reason why this is going to become under root 3 is because that if we have a into b, for example, it is a into b under root. So sec square theta's square is going to get cancelled with under root 3 with under root, and then we're going to have under root 3 over here. I hope so you understood that. So we have sec theta over here, sec theta multiply by under root 3 sec square theta d theta. So what do we see over here, that this theta and this theta is going to get cancelled. Oh sorry, under root 3 and under root 3 are going to get cancelled, and then we have sec theta and this is going to get cancelled. So what are we only left with is equal to pi by 6 over pi by 3 sec theta d theta. So now we're going to integrate this with respect to theta. So now what the main question is, what is the integral of sec theta? Because that isn't part of our syllabus. The sec theta integration isn't part of the syllabus. So what you're going to do is you're going to go back to the question, and you're going to see that the derivative of ln sec x plus tan x is sec x. So we know that the integration is a reverse process of differentiation. So if I'm going to integrate sec x, so I'm again going to get ln sec x plus tan x. So what is the derivative of what is the integral of sec x? It's ln sec x plus tan x, because integration is a reverse process of differentiation. If I have this, if I you differentiate this first, if I differentiate this, I'm going to get sec x, and if I'm going to integrate sec x, and I'm going to get this. So this is how it is done. So we have is equal to ln sec x plus tan x. I hope so you understood that part. Pi by 6 over pi by 3. So now what we're going to do, we're going to substituting the limits. Sub the limit, substituting limits. So what we're going to get ln 1 over cos sec x is 1 over cos, so that is the reason why I've done it, plus tan pi by 3, right, minus ln 1 over cos pi by 6 plus tan pi by 6. So let's pick up a calculator and see. So simply 1 over cos pi by 3 is, it's simply going to give us 2. Now this is 2 plus. Now let's see what is tan pi by 3. It's under root 3. Minus, sorry, I'm writing this over here, minus ln. Now see what is cos 1 over cos pi by 6. It is 2 root 3 over 3 and plus. Now let's see what is tan pi by 6. It's under root 3 over 3. So if you see one thing over here, ln 2 plus root 3. Root 3 over 3 is common over here, so I'm going to take that common, minus root 3 over 3 is common, and what is remaining inside, it's 2 plus 1. And what is 2 plus 1? 2 plus 1 is 3. So that 3 and that 3 is going to get cancelled. So what do we see that 2 plus 1, 3 and 3 are going to get cancelled. So I'm just going to get cancelled over here, sorry. So and then we're left with ln, this is 2 plus root 3, 2 plus root 3 minus ln under root 3. So we know that from a logarithmics chapter, when we have ln a minus ln b, so what is it equal to? It's equal to ln a over b. So I can simply, using that, I can simply write it as is equal to ln 2 plus root 3 over root 3. So this is our answer, and with that I conclude this video. So I hope so you like the video, you understood the concept. So please do like, share and subscribe to my channel. See you in my next video, and yeah, that's it.